Hey, good morning. So for today, we're gonna kind of expand upon our work from yesterday. So yesterday we talked about how to go from vertex form or factored form to standard form. And so it turns out that things aren't always nicely writable in the other two forms, and standard format comes in handy. It also turns out that we can go from standard form to finding our x-intercepts. So a few critical pieces to remember. Remember, x-intercepts are where the parabola crosses the x-axis. And because of that, the y value is always 0 at the x-intercepts. And finally, a parabola can cross the x-axis in 0 spots, 1 spot, or even 2 spots. So this is the absolute maximum. It would be impossible for a parabola to cross any more than 2 times just because it's that U shape. That's not a U, that's like a W, but you get what I mean. So if we take a look at how to solve from standard form for x-intercepts, the first thing to note is that fact that the y value is 0. So when I'm trying to solve, first thing I'm going to do is change the y value to 0. That's step 1. All right, step 2 is I'm going to factor this. So if you remember, I'm just going to create my box, throw my x squared in, throw my positive 6 in. I already know that x times x is going to be x squared. But now remember, I'm trying to find factors of positive 6 that will add up to positive 5. So I got 1 and 6, and then I have 2 and 3. Well, since it's a positive 6, my factors either have to both be negative or both be positive. So if both of these are positive or both of them are negative, those won't combine to be 5. But if both of these are negative or both of these are positive, they combine to get me 5. And it turns out they both have to be positive to get positive 5. All right. So in other words, I'm going to say these are my factors. And just to confirm, positive 3 times x is positive 3x. X times positive 2 is positive 2x. And sure enough, if I look at these, they're going to add up to a positive 5x. So I know I'm good. All right, so now all I'm going to do is say, rather than standard form, I'm now back to factored form. And if you notice, we're looking for the x values that are going to make this 0. So in this case, I bet you can see that if x equals negative 3, that's going to be one possibility. And if x equals negative 2, that's going to be another option. So in other words, my two x-intercepts are negative 3, 0, and negative 2, 0. All right, so once again, this is just taking us back to our skills from earlier in the semester, where if I have something with an x squared, I know I can factor it. Factored form, I'm looking for the x-intercepts, so where y is 0. And so it turns out the x values in this case are negative 3, because negative 3 plus 3 is 0, and negative 2, because negative 2 plus 2 is 0. All right, and we can always take a look here at the graph just to verify. So sure enough, I can see that my x-intercepts are at negative 3, 0, and negative 2, 0. Sweet. All right, so let's take a look at example 2. Example 2, notice how the value in front of x squared is not 1. So if possible, I want to think, is it possible to simplify this a little bit? So first off, remember my y value is going to be 0. So the only thing that 3 can be divided by to get a whole number is 1 or 3. So can this be divided by 3? It can. That would get me 7. Can 36 be divided by 3? For sure. That'll get me 12. And And so since I can divide everything by 3, I'm going to put that 3 in front of parentheses and then make sure I've divided all the terms. So 3 divided by 3 is just 1, 21 divided by 3 is 7, 36 divided by 3 is 12. So now I have this with the 3 outside. So now I'm going to take my box and I'm going to factor this remaining quadratic. So x squared, positive 12. All right, factors of positive 12 are 3 and 4, 2 and 6, 1 and 12. So as long as both factors are positive or both factors are negative, that'll get me a positive 12. All right, I know x times x is x squared. Now I'm thinking, which of these may combine to get me a negative 7? Probably not this, but I think 3 and 4, if they're both negative, will get me a negative 7. And I know that a negative 3 times a negative 4 is going to be a positive 12. So now negative 4 times x will be negative 4x. X times negative 3 will be negative 3x. And if I think about adding these together, sure enough, that'll be a negative 7x. All right, so now that means my totally factored form looks like this. So just a quick reminder, remember, if the number in front of x squared is not 1, see if you can simplify the quadratic by dividing them all by the same number. If they are all divisible, then you can make it simplified. If not, you got to work with what you got, and we'll talk about that in a minute. All right, so now if I think about what x values will make this 0, well, I'd have to have a positive 4 for x to make that happen. So x equals positive 4 is one option. And then looking at this one, x would have to be a positive 3 to make this 0. So x equals 3 is my other option. So in other words, 4, 0 and 3, 0 are my x-intercepts. And sure enough, if I go to the graph, both of those are the x-intercepts. Alrighty. So let's look at a couple more complex situations. All right, if we look at example 3, I notice that the number in front of x squared is 4. And 4 can be divided by 1, 2, or 4. So I can divide 4 by 4. I could divide 12 by 4, but I can't divide 9 by 4 and get a whole number, so can't simplify that way. I can divide 4 by 2, 12 by 2, but once again, I can't divide 9 by 2. And so I'm kind of out of luck. I can't make this any nicer by factoring out a number, so I got to work with what I've got. So I'm still going to make my y value 0, but sadly, there's nothing I can do to make this easier. So I'm going to have to go with a box. All right. So the other difficulty about this one, actually I'm going to make 2 boxes. I'm going to test one I know is wrong, and then I'm going to test one I know is right. So first off, I know that this, instead of just being an x squared, it needs to be a 4x squared. And this needs to be a positive 9. All right, so I've got a few options. I can turn 4x squared into 4x and 1x. And then maybe for 9, I try positive 3 and positive 3. Well, positive 3 times 1x would be positive 3x. And positive 3 times 4x would be positive 12x. If I look at these, those certainly do not combine to be 12x, they combine to be 15x. So I know that this is incorrect. Let's take another shot. All right, 4x and 1x was possible, but that's not the only thing. 2x squared could also be 2x and 2x. So I'm going to try 2x plus 3 and 2x plus 3. Well, 3 times 2x would be positive 6x. 2x times positive 3 would be positive 6x again. And if I look at these, those are definitely going to combine to be 12x, and so I'm good to go. So if this still hadn't worked, I could have always tried 1 and 9 here. So just remember that. You've got, in a case like this, you have options for not only the x terms, but also the factors here. All right, so now my goal is to figure out what x values make this 0. And this one's not easy because remember in the other cases it was just x plus 3, x minus 4, and it was pretty quick to figure out what made it all 0. In this case, 2 times something plus 3 needs to be 0. It's a little bit harder to figure out. So rather than trying to guess and check until I get there, what I can do is I can say, when does this happen? So once again, in a case like this, it was easy to see that negative 3 plus 3 is 0, and so that was just my x value. But once again, in this case, 2x plus 3, when does that equal 0? I don't know. I can't just see it off the top of my head, so I'm just going to set it up and then solve. All right, and then I'm going to divide both sides by 2. Negative 3 could be divided by 2 for a decimal, but decimals are lame. So let's leave it as a fraction. All right, so sure enough, I'm finding out that negative 3 over 2 must be my x value. So there's one x-intercept. You're probably going to notice something interesting. If you think about this one, this side's exactly the same, so that's probably going to get me the exact same x-intercept in this case. I mean, I can set it up for you again if you want, but I'm just going to subtract 3 from both sides. That'll just be this, and then I'm going to divide both sides, and sure enough, that's just going to be the same exact number. So in a case like this, where the two possible x values are exactly the same, this is a case where you only have one x-intercept. So one more rundown. I said the factors for this are 2x plus 3 and 2x plus 3. Because I can't easily find out what x value makes this set of parentheses 0, I had to set it equal to 0 to figure that out. And so let's go and check our graph. Notice how, sure enough, this parabola only touches in one spot, and that happens to be at negative 1.5, which is the decimal version of negative 3 over 2. So we're good to go. So our factored form is great because even if there's only one possibility, it results in only one possibility. All right, finally, let's take a look at 4. 4 on the surface doesn't look bad because it's only an x squared, so that's nice. But now the problem is, you're probably noticing that the only factors of positive 13 are 1 and 13. X times x is x squared, but if 1 and 13 is my only combo, I could try the positive and the negative version, but I'm pretty certain that these don't combine to be 7x. And the negative version is just going to do the same thing. So it turns out in a case like this, it's not factorable. And if we take a look at the graph, you might notice that there aren't any x-intercepts. Our parabola is actually above the x-axis, and so it never crosses. So when we see something's not factorable, take a look at the graph and see, does it cross? If it doesn't, then there's no solution. So not factorable doesn't necessarily mean there's no solution. We'll look at cases later this week where something can be unfactorable but still have X-intercepts. They're very special cases, but for now, when you see that something, no matter what you try, is not factorable, head to the graph and look, and odds are you're going to see that there's no solution. All right, that is today's lesson. Please email me if you have questions. Otherwise, good luck, and don't forget to sign up for things tomorrow if you need some extra help.